Welcome to Mythos AI, your source for Cliff's Notes on complex subjects. Join Anna and Phil for yet another engaging conversation.
Welcome to the deep dive. Today, we're really diving deep into the world of AI with a true innovator, Andrej Karpathy.
It should be fascinating.
We're going beyond the headlines today to uncover what makes Karpathy tick, what he's achieved, and why it matters to you.
He's definitely an interesting figure, and his work has had a huge impact. I'm excited to see where this deep dive takes us.
We'll trace his journey from those early days to becoming such a major player in the world of AI. And trust me, this isn't your average tech biography.
Yeah, it's anything but typical, right?
You could say that. There are some surprising twists and turns along the way, so buckle up. So, are you ready to decode the mind behind some of today's most exciting AI?
Absolutely. Let's get into it. What I find most fascinating about Karpathy's story is how it reflects the evolution of AI itself.
It's true. His work has always seemed to be right on the cutting edge.
And he didn't exactly emerge from Silicon Valley like so many others.
Right, it's not the typical Silicon Valley story, so where do we begin?
His journey began in a place you might not expect. Bratislava, 1986.
Bratislava, 1986. Not your typical AI origin story, is it?
Not quite. But then moving to Toronto at age 15 was a pivotal moment for him. It really opened his eyes to the world of computer science.
It seems like that move was a turning point for him.
Like he stumbled upon a hidden talent. And this wasn't some preordained path. It was a choice, a turning point, just like the ones we all face in life.
And he really dove headfirst into computer science after that. Our sources say he double majored in computer science AD physics at the University of Toronto.
Now that's impressive.
That's impressive on its own, but what do you think that tells us about his approach to AI?
It really reveals a mind that wants to understand how things work at the most fundamental level.
So it's deeper than just wanting to build something that works. It's about understanding the why.
Exactly. Physics isn't just about equations. It's about the underlying principles of the universe. And I think Karpathy brought that same deep thinking to computer science.
So for him, it's not just about coding, it's about grasping the very building blocks of information and intelligence itself.
Exactly. And that's where his master's work at UBC gets really interesting. He focused on physically simulated figures.
Physically simulated figures, what does that even mean?
It might sound a little niche, but it has huge implications. Think of it. How do we get those incredibly realistic animations in movies or video games these days?
Right. Or even think about virtual reality. That level of realism, being able to recreate it digitally like that, requires a deep understanding of physics and movement.
Precisely. Karpathy's early work was about more than just cool visuals. It was about teaching computers to understand and interact with the physical world.
So from Bratislava to Toronto, then diving into the complexities of simulation, it sounds like Karpathy was already building a pretty unique set of skills by this point. Almost like he was gathering all the ingredients for something groundbreaking, wouldn't you say?
And that, my friend, is where his journey takes us next, to the halls of Stanford. And trust me, this is where things get really, really exciting. So picture this. Stanford University, a hub of innovation, and a young Andrej Karpathy working on his Ph.D. under the guidance of Fei-Fei Li.
Fei-Fei Li. Now, that's a name I've heard before, but for our listeners who aren't as familiar with the AI Hall of Fame, who is she and why is this mentorship such a big deal?
Well, imagine stepping into a top-tier music studio, right? And you get to work with a legendary producer. That's kind of what we're talking about here. Fei-Fei Li is a giant in the world of AI, particularly known for her groundbreaking work in computer vision.
Computer vision, so that's basically teaching computers to see, to make sense of images like we do.
Exactly. And Li's work on image recognition was revolutionary. Imagine being mentored by someone who's basically writing the rulebook on how AI understands images.
So for Karpathy to be learning from her firsthand at Stanford, that's an invaluable experience. And it's right around this time that his own research on image captioning starts to take off. Right?
So that's where things get really interesting.
Image captioning. Okay, for those of us who might not be as tech savvy, can you give us the ELI 5, explain it like I'm 5 version of what that is?
Of course. Imagine you're scrolling through, your social media feed, and you see a picture, but there's no caption, no description. Image captioning is all about teaching AI to do what seems so effortless to us humans. Actually describe what's happening in that image using natural language.
So more than just tagging an image with some keywords, it's about the AI understanding the actual context of what's going on in the picture.
Precisely. It requires the AI to recognize objects, understand their relationships to each other, maybe even grasp the subtle nuances of the scene, the emotions. It's a huge leap forward in terms of AI comprehension.
No wonder this kind of research had such a big impact. It's kind of everywhere now that you mention it. I use apps that help me organize my photos based on what's in them. I've even seen ones that can describe images for visually impaired users. It's easy to forget that someone had to, figure all that out, make it happen.
Absolutely. Karpathy was one of the pioneers in this field. He really helped bridge that gap between simply seeing images and actually understanding and describing them with words. And his work at Stanford wasn't just about pushing the boundaries of what AI could do, it was also about making it accessible to others, which leads us to his blog post, The Unreasonable Effectiveness of Recurrent Neural Networks.
Okay, confession time. Whenever I hear people start talking about neural networks, my eyes kind of glaze over a bit. It feels very technical, very complex.
Yeah.
So how did he manage to make this topic understandable for the rest of us?
Well, that's the beauty of Karpathy's approach. He's a natural teacher. He has this incredible knack for breaking down even the most complex concepts in such a clear and engaging way. It's like he's inviting everyone on this journey of understanding AI. You don't need a Ph.D. in computer science to follow along.
That's so important, especially in a field that's evolving so rapidly. I can see how it'd be easy to feel lost or intimidated, but Karpathy seems to want to bring everyone along for the ride.
Exactly. And it's this desire to push boundaries, to really explore the forefront of AI, that leads us to another significant chapter in his journey, his time at OpenAI. And this is before ChatGPT was making headlines, back when OpenAI was just starting to make waves in the AI community.
So what was OpenAI working on back in those early days, and what was Karpathy's role in all of it?
They were already doing some really interesting research, particularly in the area of deep learning. And Karpathy was there right at the heart of it, a founding member, actually.
Wow, a founding member. That speaks volumes about his standing in the AI community, even back then.
It really does. And at OpenAI, he was particularly focused on something called reinforcement learning. You ever heard of that?
Reinforcement learning. It rings a bell. It sounds familiar, but I'd love to hear you explain it. What is that exactly?
Okay, well, imagine you're trying to teach a dog a new trick, right? You might use rewards and maybe a little correction to guide its behavior.
Right, a little positive reinforcement.
Exactly. Well, reinforcement learning is kind of similar, but for AI. It's about creating AI systems that can learn through trial and error, just like we do, becoming better at tasks over time.
So instead of needing a programmer to explicitly program the AI for every single scenario, it can learn on its own by doing, experimenting, even making mistakes along the way.
You got it. It's like playing a video game. You learn the rules, you make mistakes, you try different strategies, and you get better as you play more and more. Karpathy was taking those same principles and applying them to all sorts of challenges in AI, really pushing the boundaries of what these systems could learn and achieve.
Okay, I think I'm seeing a pattern here. Stanford, OpenAI. Karpathy seems drawn to places that are really at the forefront of AI innovation. He's not just following trends, he's actively shaping the future of the entire field.
Absolutely. And this drive to apply his knowledge to real-world problems, that's a key part of his story. And it leads us to perhaps his most well-known role yet. You ready for this?
I think so. Hit me with it.
Buckle up, because we're about to head to Tesla.
Tesla. Talk about a company that's really pushing the limits, especially when it comes to AI. So Karpathy joins them as director of AI. That's a huge role. What kind of challenge are we talking about
Look,
here?
it's not like building the next big social media app, right?
Yeah.
This is AI with real-world implications, high stakes. People's lives are potentially on the line.
Exactly. This is about changing the way we think about transportation. So what was Karpathy brought in to do?
His mission, should he choose to accept it, was to make Tesla's vision of self-driving cars a reality.
Okay, self-driving cars. Even a few years ago, that felt like something out of science fiction. Where do you even begin with something that ambitious? I mean, you're talking about teaching a machine to navigate the real world to make split-second decisions.
It's a different ballgame entirely from image captioning.
Right. You can't just feed an AI a bunch of data and expect it to understand how to react to a pedestrian suddenly stepping into the road or something.
You're hitting on a key point there. Traditional AI, for the most part, it relied on these relatively small data sets, very controlled. But Karpathy, he had something much bigger in mind, something called fleet learning.
Fleet learning. Okay, now that does sound like something out of Star Trek.
Right.
Break it down for us. What is fleet learning?
So imagine millions of Tesla cars, all those cars out on the road right now, all equipped with Sensors, cameras, constantly gathering data about their surroundings.
Oh, I see where you're going with this. So each Tesla is constantly feeding information back to some central AI brain somewhere.
Exactly. Karpathy envisioned using this massive fleet of vehicles as a giant learning system. So every mile driven, every traffic light encountered, every pedestrian, every cyclist, it all becomes part of this massive data set that the AI is constantly learning from.
So each Tesla isn't just a car then, it's like this data collection point, contributing to this constantly evolving AI.
Precisely. And this approach, it allows Tesla's AI to learn from those real-world scenarios on a scale we've never seen before.
Right.
We're not just talking about building a single self-driving car here. We're talking about creating an entire system that's getting smarter with every mile driven by every Tesla.
Okay, that's incredible and a bit mind-blowing when you really think about the sheer amount of data we're talking about here. But this idea of fleet learning, this goes way beyond self-driving cars, doesn't it? This concept of AI learning from massive real-time data sets, that has the potential to revolutionize, well, everything.
And Karpathy saw that potential early on. It's where his vision of Software 2.0 comes in. He was arguing that we're on the verge of a software revolution, a revolution where AI isn't just a tool, it's the architect.
Software 2.0. Okay, I'm intrigued. So in this Software 2.0 world, what does that look like? Paint us a picture.
Imagine a world where software can write and adapt itself based on the data it's receiving. So instead of needing programmers to write out line-by-line instructions, you simply give the AI goals and access to data, and it can figure out the optimal solutions on its own.
So it's constantly learning, constantly evolving.
Constantly. It's like giving the AI the building blocks, showing it the blueprint, and then letting it not only build the structure, but also redesign it, make improvements over time, all based on how it's being used in the real world.
Wow. It's clear Karpathy is a true visionary, someone who isn't afraid to challenge how we think about things. And what I find even more impressive is that it's not enough for him to just see these possibilities himself. He wants to share them with others.
Absolutely. Knowledge sharing is such a crucial part of what he does.
Right. He returns to OpenAI, then branches out on his own, all the while he's actively promoting open access to AI knowledge, making sure that anyone who wants to learn has that opportunity.
He's not trying to gatekeep any of this knowledge, which I think is so important, especially with a field that's evolving as quickly as AI.
And that brings us full circle to why we wanted to do this deep dive in the first place. We've explored Karpathy's journey from his early days in Bratislava all the way to the cutting edge of AI. But what I hope our listeners take away from this is that you don't have to be a coding whiz to understand and even shape the future of AI. And Karpathy embodies that idea better than anyone.
His story shows us that anyone can make a difference. His dedication to sharing knowledge, to breaking down complex ideas, it's really inspiring.
He's not just building the future of AI, he's opening the doors for all of us to join him on that journey. And who knows, maybe someone listening right now will be inspired to become the next Andrej Karpathy.
I hope so. That's what it's all about.
It has been fascinating. Thanks for joining us for this deep dive, everyone. Until next time.
Thanks for listening to Mythos AI. Stay tuned for more concise insights. And remember to hit the like button and subscribe for future episodes.